Hello, in this work we propose a novel approach for screening alcohol dependence using user-game interaction patterns. Long-term excessive alcohol use can cause significant brain damage, resulting in cognitive deficits and reduced motor control. According to 2018 Public Health England, more than 500,000 people were alcohol-dependent drinkers. However, only 18% of them ever received treatment. Given that current diagnostic and screening measures for alcohol dependence rely on self-reporting, and the procedure are time-consuming and must be administered by trained clinicians, these limitations led a call for an alternative approach. Alcohol dependence is often manifested with specific cognitive decline and reduced fine motor control. We consider that both of these changes can influence the way users interact with mobile games. In this work, we use 3 casual mobile games running on mobile devices. It is Tetris, Fruit Ninja, and Unblock Puzzle. 3 different feature sets were extracted during user-game interaction. These include gameplay performance, touch interaction, and device motion. The study sample was drawn from 40 male patients diagnosed with alcohol dependence. A control group of 40 age and gender-matched healthy adults were recruited through public advertising. In the experiment, participant cognitive function was examined using standardized cognitive tests. Next, participants were given an introduction on how to play all the 3 games. To reduce the effect of participant prior game experience, they were asked to familiarize themselves with the games, each game for 5 minutes. Afterwards, participants were asked to play each game for 10 minutes in random orders to avoid audio effects. User-game interaction patterns were then collected during the gameplay. Based on the data collection, 3 sets of features were computed using the entire data samples. For the touch interaction, data cleansing was also carried out to remove the faulty touch data points that might occur from unintentional touches while participants held the phone in their palm. 3 supervised machine learning methods were employed to develop binary classifiers to identify patients from healthy control. As the observed class labels were balanced, accuracy was used to evaluate the model performance. Stratified tenfold cross-validation was used to generate training and test sets with a balanced distribution of classes. Comparisons were made on model performance over 5 different feature sets to investigate the effect on accuracy. The 3 plots on the slide demonstrate the model performance using the data of each game as input. The x-axis represents the feature set, while the y-axis represents the mean accuracy. The bar color represents the classification algorithms. By comparing the overall results, using combinations of multiple feature sets as input improved the model performance in classification accuracy as compared with using only a single set of features. It is noted that logistic regression shows the highest mean accuracy of 0.96 when using the ensemble of touch and sensor features from Tetris. Given that an ideal alcohol screening measure should provide accurate results within a short time, we further examined the model performance on 3-minute samples. To this end, the original 10 minutes data was truncated to the first 3-minute samples. Logistic regression and random forest were trained on the combinations of all feature sets. For both Tetris and Unblock Puzzle, the random forest classifiers on 3 minutes data shows even better results when compared with the model on 10 minutes samples. In particular, the model using 3-minute samples of Unblock Puzzles could achieve 95% accuracy. In contrast, the performance of logistic regression seemed to drop significantly when using 3-minute samples. We then further examined the sensitivity and specificity of our classifier, as they are more common measures for assessing the performance of clinical tests. The random forest classifier on 3-minute samples of Unblocked Puzzle still demonstrates promising results. In particular, the model achieved 95% sensitivity and specificity. Our key finding: with regard to classification performance, our game-based approach outperformed both conventional paper-based screening tools and the EEG-based methods. In addition, the game-based screening instrument is robust, fast, portable, and requires only minimal effort to implement. In contrast, the EEG data acquisition often takes a long time for equipment setup and calibration, which can be administered only by trained clinical staff within clinical premises. One possible implication is that our game-based measure could help facilitate the brief self-screening in the waiting area prior to seeing the doctor. The result from the measure could assist the therapist in decision-making and planning for further examination. In addition, patients may be prescribed the mobile game-based screening application to monitor for early signs of relapse to harmful alcohol use. Thank you.